So I've got a web page, the university. I don't know why. They don't even link to them anymore. They used to be able to go in and get to it through the university's whatchamacallit, their little tree that they have there, but you can't do that anymore. So, and I don't know why. This thing's completely out of date. I haven't touched it in years. But there are some tests up here, at least for this unit. So here's the address up here. If you just go to http, people.missouristate.edu/ and then my name, David Mitchell, all one word, and here's what you get. If you come down here to the principles of micro, even though this is a principles of macro class, remember I said the first unit in my micro and micro and macro classes is completely identical. Same material, same stupid jokes, same everything. Everything is completely identical. I don't even have notes today, right? Because parts of Unit 2 for principles of micro and principles of macro are completely identical. I mean, it's all the same. I was like, why am I continuing to bring these notes? I already know exactly what it is I'm going to say. I'm just wasting my time. So you can come here to the principles of micro, right? And you click on this. My daughter's like almost a freshman in high school. That's how old this is, right? I mean, she's old, and this is fall 2006, right? So, but there are some sample tests here, right? So you've got these tests here. So this is from, you'll notice, from fall of 2002. But once again, I mean, like, supply and demand stuff doesn't change. I mean, there's nothing that changes about this stuff. It's all identical. So you can come down here, you can kind of take some of these sample tests if you want to. And think of the answers down here. Yeah, this one has the answers down here at the bottom, right? Now some of these you'll notice, like this stuff right here is talking about rent control and stuff like that. We're moving that in Unit 2, right? So not everything is going to match up because I move things around sometimes. Sometimes I've had 3 tests in the past. Sometimes I've had 4. Sometimes I've had 5. Sometimes I've had 2, right? I do different things. But some sample questions for you. And then there's another one here. And this one says another example. And I think it's another example because you'll notice the font is all different. And this is not so the other one, I write my own tests. I don't use the test banks that other professors do. Other professors just have them randomly pull questions from their test banks. I don't do that. I write all my questions. This is a test bank question, right? So people are like, well, give us more examples, blah, blah, blah. And I was like, all right, fine. So here's randomly selected Unit 1-ish kind of test questions. And I think the answers are on this one too, but I don't, yeah. So there's the answers for that one. So you have some kind of sample test questions and things like that. Once you get to test 2 and 3 and 4, sorry. But you got something for test 1. So just something to think about if you want to take advantage of that. So it's up to you. I don't. Doesn't matter to me. So what we want to look at today is taxes. And there's more to it than just saying, oh, it's this change in supply here, right? We know that one of the things that shifts the supply curve is things like taxes, right? So let's kind of look at a very, very simple guy here. So there's our quantity, here's our price, here's our demand, here's our supply, right? And let's assume that we're looking at, just make anything, we'll just make it say gasoline. Okay, so we have an equilibrium price here of $1, and let's give ourselves an equilibrium quantity of 100. Okay. So, like we said, first thing before we do anything, we want to draw our initial equilibrium conditions, which we've done. So we have 100 here. We have $1. Okay. Now let's put a tax of 50 cents on this market. And what that means is that we know the supply curve is going to shift, right? This guy's going to shift left. He's not going to shift right. Right? And this distance here this vertical distance right here is 50 cents. Right? And it's the same vertical distance throughout this entire guy. Now, before we look at this price quantity combination that we're looking at now, ignore the green line. Just look at the black line. Tell me what the black line says. I mean, what do these guys mean? What do these guys tell us? We've gone over this a gazillion times already.
It costs $1 to make the 100.
Exactly. And the 100th is worth $1, right? We've done that a gazillion times already. Right? So we have this 50-cent tax on gas, and we see here we're going to get a price here, say $1.25, and we're going to get a quantity here of, say, 90. Right? So we have this tax of 50 cents. We've got an equilibrium price of $1.25. We have an equilibrium quantity of 90. Now here's the question. Why didn't the price go up to $1.50? Because remember, taxes are a cost to firms. Right? So there's this tax of 50 cents that we put on the firm. But we're not seeing price go up to $1.50. We're seeing price go up to $1.25. Let's put it this way. How much does the 90th gallon of gas, how much is it worth? $1.25. How much does it cost to make? Exactly. He actually cost 75 cents to make. Why don't the firms make more gas? Because we know what it actually really physically costs to make the gas, right? 75 cents to make that 90th gallon. People are willing to pay $1.25. We should keep making gas. Why do we stop?
Then wouldn't it be worth like $1.75 for the consumer? Like with the tax?
Basically, the tax is like an artificial cost that's put on top of it. Does that make sense? And so at this, the real cost of gas is 75 cents for this 90th gallon, but now we have this 50-cent tax on top of it. It's kind of an artificial cost, which brings us up to $1.25. So in essence, what we have here is this 90th gallon of gas costs 75 cents to make. Firms should keep making more, but they're not going to because this artificial cost is put on top of gas, on top of the real cost of what it takes to make gas, making us get all the way up here to this $1.25. Here's an alternative way to think of it. You go to the store and you give the guy $1.50. If I give the guy $1.50, he's going to give 50 cents of that in tax to the government. He has this dollar that he's going to give to, that's going to cover the cost of making gas. If firms are getting $1 for making gas, how much gas are they going to make? They're going to make 100, right? Does everyone see that? 50-cent difference right there, right? If they're able to push the full cost onto consumers, the price would go up to $1.50. They would continue to make the same amount of gas before. Now here's the problem. At $1.50, how much gas do consumers want to buy? Less than 90, whatever that number is, 80 or whatever. Surplus or shortage? Surplus. Surpluses do what to prices? Drive them down, right? So they're not going to be able to shift all of this cost they can shift some, but not all. Okay? So now we have something here that we can learn a lot of information from. Because what we want to know is we want to know, well, how much tax revenue are we going to collect? It's pretty simple to figure that out, right? We have our tax times our quantity, right? That's going to be our tax revenue. So 50 cents here times 90. We're going to collect $45 in taxes, right? And I'm sure by now you've probably started to figure out that every single one of these areas on here means something. It's not just random stuff. So what we have here is that here's our tax, right? 50 cents. Here's our quantity. So this guy right here, I'm going to do this guy in blue. This guy right here is the area of this guy represents our total tax revenue. Now, consumers pay taxes and higher prices. What price did they used to pay? They used to pay $1. Now they pay $1.25. So if we want to know how much tax revenue comes from consumers, we have the tax that are paid by consumers once again times our quantity, right? Well, this guy here in blue is our total tax revenue. The tax used to be, what color do I want to use here? The tax used to be, I'll use that. Use this guy. Price used to be $1, now it's $1.25, right? So this guy right here of tax revenue represents the amount of tax revenue that's coming from consumers. It's how much tax revenue consumers are paying in the form of higher prices. It's this guy right here, and I'm going to highlight here in red. I've been doing this. So we're going to call it this guy over here. Right. So if we want to figure out what that is, it's pretty simple. Right? They're paying 25 cents. Paying 90. They're going to be paying $22.50, right? Producers pay taxes and lower revenues. They used to get $1, now they're getting how much? They used to get $1, now how much are they getting?
50 cents.
Getting 75 cents, right? The price is $1.25, 50 cents of which goes to the government in the form of tax. 75 cents is left over to cover all of the cost of what it takes to make gas. I'll do that guy in, I guess, black here. So here's this guy. So here's our tax revenue that is paid for by our consumers, or by our producers. It's this guy. $25 times 90, $22.50. We know what this guy is. This guy's consumer surplus. We know what this guy is. This guy's producer surplus. This guy right here represents total variable cost or total fixed cost if you're looking at this in the long run. What's this guy right here? It's lost, not necessarily revenue. I mean, you could think of it like that, but it's more than that. How much is the 90th gallon of gas worth? $1.25. How much does the 90th gallon of gas cost to make? 75 cents. Should we make more gas? Ignore this. We're here. Yes, keep going, right? Because you got 90 cents or 75 cents worth of stuff, we can rearrange it into something that's worth $1.25. People are better off. It makes sense to keep making more. Will we make more? No, we'll stop, right? And so there is consumer surplus and producer surplus, right? In order to get the maximum of consumer surplus and producer surplus, we've got to make right here. But we're not making there. We stopped here at 90. So what we have here is we've got consumer surplus and producer surplus that never comes into existence. It never gets created. We actually have a name for it. We call it a deadweight loss. And if we want to know the size of that deadweight loss, it's pretty simple. It's just a triangle. What's the formula for the area of a triangle? Right? Just 1/2 base times height, right? A triangle is just a square cut in half. Base times height tells you the area of the square or the rectangle or whatever. Taking half of that tells you the area of the triangle. So, here's our base, here's our height. So we've got a base here, 1/2, 50 cents times 10, right? That times that is 5, taking half of that, $2.50. That's what that area represents. So we know what the dollar value of that is, but let's put that into practical terms. When we say a deadweight loss, I mean, what do we actually mean by that? Here's our 100 gallons of gas. Here's our 90 gallons of gas, right? Does it take, which one takes more resources to produce? 90 or 100? 90. 100, right? It makes more resources to take 100, right? It doesn't take more resources to make 90. It takes more resources to make 100, right? So, we have these 10 gallons of gas, and we know that we had resources making these guys. What are these resources doing? We know what these resources are doing. These resources are making gas. These 10 gallons of gas here, what are those resources doing? Bless you. It's the change in the weather, isn't it? I can't even hear it on my right ear. I woke up this morning and was like, did I go deaf? What are these guys doing? What are these resources that made these 10 gallons of gas, what are they doing? Very good. They're being used for something else. Or what? Very good. Go all the way back to our production possibilities curve. If we have resources sitting idle, where are we on the curve? We're inside, right? In order to be on the curve, we had to use all of our resources. All of our resources were being used. We didn't have any resources sitting idle. So if these resources are sitting idle, if they're not being used, we've moved inside. Alternatively, now they're being used for something else. We said in order to be on the curve, all of our resources have to be used, and our resources have to be used where they're going to have the greatest effect on output. In other words, they're being used where they have a comparative advantage. And these resources have a comparative advantage in making such and such, so we're using them to make such and such. If we have resources not being used where they have a comparative advantage, we're inside, right? You can have full employment and still be inside the production possibilities curve. You can hire people. You can say, medical doctor, we don't want you being a medical doctor anymore. We want you digging ditches. You can do that. That's what China did. They actually did do that. They said, you got all of these professionals here, all these doctors and lawyers and engineers and stuff. You people suck. You need to go back to the farm and learn how life is. And so they took all the doctors and lawyers and engineers out. And if you didn't want to go, it didn't matter. You were going. And they stuck them back to a farm. Well, they don't know anything about farming. And the people behind them didn't know anything about doctors and lawyers and engineering and stuff like that. And it was a complete disaster. You had full employment, but you moved way inside your production possibilities curve. We know these resources that were here were being used. They had a comparative advantage in making gas. I mean, let's assume that rather than making gas, they're making toys. How do we know they had a comparative advantage in making gas and not toys? How do we know these here's resources. They were making gas. Now, thanks to the tax, they're not making gas, they're making toys. How do we know they have a comparative advantage in making gas? Well, it could be anything. It could be labor or anything. You're close. If they had a comparative advantage in making toys, what would they have been doing in the first place? Making toys. So the fact that they're now being used for something else, they've come out of gas and oil production, and now they're being shifted to something, it's toys. It's completely stupid. Tells you they didn't have the comparative advantage of making toys, they had the comparative advantage of making gas because that's what they were doing in the first place. In other words, this deadweight loss measures kind of how far inside you're coming. That's what he does. That deadweight loss tells you how far inside this PPC am I. Let's look at another example. Let's say we're looking at the market for cigarettes. And let's just assume we have the exact same price and quantity here. Got the supply curve basically the same. You will notice the demand curve is a lot steeper. So now we're looking at the market for cigarettes, right? We have an equilibrium price of $1. We have an equilibrium quantity of 100. Let's put the same 50-cent tax on here. Because in essence, the state legislator says we want to tax cigarettes because we want to create more revenue and we want people to, we want this large reduction in smoking. All right? You guys ever heard a state legislator say that? If you have a large reduction in smoking, where's the revenue going to come from? You don't get the revenue. Okay, fine. So if you have the huge increase in revenue, that means people didn't quit smoking, right? You can't have both of those. When you hear a politician say that, we're going to tax this because we want this huge reduction in smoking and we want to create a whole lot more tax revenue. You're not going to get both of those. So here's our supply plus our tax. Okay? And we're going to have an equilibrium. I'll call this guy, say 90. Let's just make him 98, just a stupid number. And this is going to be, make this guy say $1.40. So now we have a new equilibrium price of $1.40. A new equilibrium quantity of 98. We got 2% of people to stop smoking. So let's run through all this rigmarole again, right? Because we've got this tax here of 50 cents. So what's this guy got to be right here? What's this number? Very good. So here's our tax. Here's our tax of 50 cents, right? Here's our quantity, right? We want our tax revenue here. We want to know, well, how much did we collect in tax revenue? Well, that's just our tax times our quantity. All right, 0.5 times 98. And I'm pretty tired, so I don't trust my math. $49. We want to know, well, how much of this tax revenue is coming from our consumers, right? So we said, hey, consumers are paying these taxes and higher prices, so we'll just use the hashed line here. So there's our portion of the tax that's paid by our consumers, right? Well, how much of the tax are consumers paying? We have a 50-cent tax. How much are consumers paying? 40. times 98. Like I said, I don't trust my math today. 39.20. Producers pay taxes in lower revenues. They used to get $1, now they're getting 90 cents. I'm going to use blue for this guy here. Here's our tax revenue that's paid for by our producers, right? So they're paying 10 cents of this guy times 98. That's our quantity. $9.80. How big is our deadweight loss? Our deadweight loss is this guy right here. All right. So we have 1/2. Our base is 50 cents. Our height here is 2. Two times 50 is 1 times 1/2. 50 cents. Why did the deadweight loss fall so much? Yeah, you only had, the tax only drove basically 2% of people away to go do something else. What if the demand curve had looked like this? Here's your supply, here's the demand. Not completely vertical, but pretty flat. In relative terms, right? I mean, there's the halfway mark right there. Well, if this is 100 and there's 50, this guy's like 30 or 20 or whatever number it is that you want him to be, right? Your deadweight loss is going to be this guy right here. It's going to be this huge amount right here, relatively speaking. We have this demand curve here. People aren't changing their behavior very much, right? We actually have a name for this type of demand curve. We call it inelastic. Consumers are very unresponsive to changes in prices. Here we call this guy elastic. Consumers are very responsive to changes in prices. We have a much larger deadweight loss when we tax these things that have elastic demands and these things that have inelastic demands. And remember, the deadweight loss is just how far inside we move. Let's assume we've got some product. It can be any product you want it to be. Q1, P1. Let's put a tax on this. Good. And so that you can see this is not some kind of graphing trick. I'm going to use the same distance here for these, right? So here's our tax. Supply plus tax, right? And we know that we're going to get some price here that consumers pay. We're going to get some price that producers receive. We're going to get some quantity here, Q2. And we know what this guy is. This guy here in green is our deadweight loss, right? Here's our consumers Here's the portion consumers pay. Here's the portion producers pay of tax revenue. This guy here in green is our deadweight loss. That's just some number, whatever it is, 12. It can be any number that you want it to be. All right, we got some deadweight loss here. That's this guy here in green. What happens if we double this tax? What do you think happens to the size of our deadweight loss? It increases, right? Is that obvious that it increases? Okay. How much will it increase? All we're doing is doubling the tax. What do you think? Double? Double the tax, double the deadweight loss? Supply plus tax plus tax. Let's do this guy here in green, black. Q3, PC2, PP3. These prices here are not very important. I'm not interested in that per se. Now the size of our deadweight loss is this guy. What did our deadweight loss do? And you can see it if you take this original deadweight loss and you just flip them in your mind. Well, if I flip them in my mind, he's that guy right there, right? Is that not a mirror image of that? 1, 2, 3, 4. What did the deadweight loss do? It quadrupled. We doubled the tax, but our deadweight loss quadruples. So if the university comes and they say, you know what, it's tuition. This sucks. We're not making enough money. We're going to put a tax on you of $2. Whatever. It can be any number you want it to be. Supply of college education plus the supply of education plus a $2 tax per hour. Then they go back and they say, we need another $2. It's going to increase the tax from $2 to $4. They doubled the tax, right? And they tell you, look, it's just doubling. It's just going from $2 to $4. It's not that big of a deal. But what happens to the size of the deadweight loss under those types of conditions? It quadruples in size. Doubling that tax does matter. The tax on cigarettes is 10 cents and they double the tax to 20 cents. I'm not saying that's a bad policy. I'm just saying the deadweight loss quadruples. If they have a tax on gas at 15 cents and they double the tax to 30 cents, I'm not saying that's a bad policy or that it's a bad idea or a good idea. I'm saying the deadweight loss quadruples in size, whatever it is. If they have a tax on red shirts and they double that tax, that the deadweight loss is going to quadruple in size. Questions about taxes? I love talking about taxes. I love it. Which means, and like I said, I write all of my own questions. This is a very easy test question to write. And I can get a whole bunch of different questions from it, right? How much is the consumer producing? How much did the producer pay in taxes? How much is the deadweight loss? How much tax are consumers paying? Blah, 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 blah. I can get 5, 6 questions from this. Guaranteed to be on the test. It's guaranteed. It will be there. Questions? So you don't need the graphing calculator on, or the calculator on test 1, but you're going to need it on test 2. Okay, I will see you guys on Monday. Have a good weekend.